Okay, part 2 of our page 16 of our linear functions booklet, we have no solutions versus infinite solutions. So for no solutions, we're going to have a false statement that's always false. And this is what I mean by that. We have 3x plus 3 is equal to 3x plus 4. So we'll go ahead and do the same thing we did on the previous examples. Subtract 3 from both sides of the equal sign. Break down our 3x. 3 minus 3 is 0. Break down our other 3x. And then 4 minus 3 is 1, so we have a plus 1. Okay, we're going to move the 3x onto the other side so the variables could be together. So minus 3x on both sides of the equal sign. Well, 3x minus 3x is 0x, or just 0. 3x minus 3x is 0. Carry down the 1. So 0 equals 1. Wait, that's false. That's always going to be false. So you can put false right here. And if it's a false statement, you put no solution. You'll get no solution if you have a false statement there. Okay, for infinite solutions, you'll get everything to cancel out eventually. You'll get a true statement. 0 equals 0, x equals x, that sort of thing. So let's look at this one. 5 parentheses 2x plus 3, close parentheses, equals 10 times x plus 15. Well, first we want to distribute the 5 into both terms. So 5 plus 2x is 10x. 5 times a positive 3 is a plus 15. And then we'll carry down the other expression on the other side of the equal sign. 10x plus 15. Well, 10x plus 15 equals 10x plus 15. That's always true. It's always going to be the same thing. And if you were to subtract everything out, you would eventually get 0 equals 0. Because of that, we say our answer is infinite solutions. All real numbers here. Anything you put in for x, you're going to get a true statement. Now, these are different than if you had x equals 0. That's a different thing. Like, for example, if we had 3x equals 0, well, if you divide both sides by 3, both sides of the equal sign, 3 divided by 3 is 1, so you have 1x equals 0 divided by 3 is 0. So this is different than if you have no solution or infinite solutions. Okay, let's look at the last few examples. Solving for one variable inequality, a graph on the x-axis. That's the number line. We have negative 4 is less than 5x plus 1 is less than 6. To do this, we're going to take away 1 from each side of the inequality symbols. So in this particular problem, we have 3 sides instead of just 2. So negative 4 and negative 1 would be a negative 5. So negative 5 is less than 5x less than 5. From here, let's go ahead and divide all 3 sides by what's in front of the x. The coefficient in front of x is 5. So we're going to divide each side of the inequalities by 5. Negative 5 divided by 5 is negative 1. Carried our less than symbol. 5 divided by 5 is 1, so we have 1x. Carried our less than symbol, and 5 divided by 5 is 1. So our solution is negative 1 is less than x less than 1. So our number line, we'll draw a hole, put negative 1, draw another hole, put positive 1. We put holes instead of dots because there's no line underneath the inequality symbols. X is in between those two numbers, so you're going to shade the middle part of this line. Okay, pause the video, see if you could do the next example. Negative 13 is less than 7x minus 6 is less than 8. Try that example on your own. You should get the solution negative 1 is less than x less than 2. And here it is on the number line. Let's look at the last one. Negative 3x is less than 12. So we're going to divide both sides by negative 3, both sides of the less than symbol. We have 1x is greater than negative 4. Now the reason why I flipped this is because we divided by negative number. If you divide both sides of an inequality by a negative number, you flip the inequality symbol. So if we're to plot this on the number line, we have our hole, put negative 4, and x is going to be greater than that, so we'll shade this side of the number line.